Hi students, this is Mr. Yao. In this lesson, we are going to learn how to work with exponential story problems. First, some warm-up questions. A. The price of an iPhone is $800. If the price went up 8%, what is the new price? 8% of 800, which means we're going to use 800 multiplied with 8%. But we can't exactly multiply with a percent, so we kind of need to change the percent into a decimal, which is 0.08. So it's 800 times 0.08, which is $64. Well, now don't you wish the iPhone is just $64? That is not the case, because it says it went up 8%. So it went up from 800, which means the $64 is actually on top of the 800, which makes the total 864. B. The price of a drone is $340. The price went down 15%, and that is 0.15 in decimal. 340 times 0.15 is $51. Same thing. You wish it's just $51, but it's actually going down $51 from 340. So this went down 15% is from the 340. 340 minus 51, the actual price is $289. In these calculations, we're doing it in 2 steps. In 2 lessons, we're going to learn how to do them in 1 steps. Now, we study linear and exponential functions because they have so many applications. In this section, we'll use exponential functions to model real-world situations. Models can help us make predictions and decisions. Let's have a look. Example 1. Radioactive substances give off energy and disintegrate as they age. This is called radioactive decay. And this is also how we use half-life to determine how old something is. There are 2,700 grams of an isotope of nitrogen that loses 2/3 of its mass every single day. The following equation is A of t equals 2,700 times 1/3 to the t power. If you recall, since the beginning of the unit, we have been writing this function for many times. F of x equals a times b to dx plus c. In this case, they look very similar, just doesn't have the plus c part. Let's understand what each part represents. A represents the amount in grams. And when we talk about what each letter or variable represents, we also want to include the units. T is pretty standard, typically represents the time, and in this case, it says every day, so T is time in days. 2,700, if you compare with the position, 2,700 is basically our A, 1/3 is basically our B. After writing the functions every single time in the previous lessons, we have also been writing down A represents the initial value and B represents the factor. So 2,700 is the initial value. It means 2,700 grams to start. Next, 1/3. Reading the question, you might be like, well, I don't see any part that mentions 1/3. However, the question said 2/3 and it's losing 2/3. If it loses 2/3, that means you have 1/3 left. So 1/3 actually indicates 2/3 decay each day, which means 1/3 remaining. Now let's put the functions into our calculator and actually complete the table. So here's the process again. We want decimals, so you're going to need to click mode to change it. And then you're going to type in y equals 2,700 times 1 divided by 3, little caret button. And x. Afterwards, you're going to click second and then graph. That's how we can get the table. And we need to start with 0 because when no time passed, the element itself was 2,700 grams to begin with. So here they are. 0 with 2,700, 1 with 900, 2 with 300, 3 with 100, etc. Now we need to graph it. Horizontally, of course, is going to be time in days. And we can label them as 0, 1, 2, 3, 4, 5, 6, 7. Vertically, we need to include the biggest number, which is in this case, 2,700. And we need to start with 0. Or you can, as you can see, there's no way we can go by 1. Go by 10 also wouldn't make sense. Go by 100 still doesn't seem to be enough. So maybe we can go by 200. And vertical axis is going to be representing amount in grams. 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600, 1,800, 22,000, 2,200, 2,400, 2,600. Okay, there you go. We almost have enough. 2,700 is just slightly above. Now let's graph them. 2,700 is around there. 900 is between 800 and 1,000. Next one is 300, and then we have 100, and then it's 33.33. Well, it's slightly below, and then it's almost getting just super close to the line. Now, the difference between this graph and the full exponential graph is you can't have -1 day. So our graph will only start with 2,700. It won't go beyond that on the left side. So no matter what, the trend of the graph is still going to be exponential. There you go. Moving on with the table, how many days will it take before there are less than 5 grams of this isotope of nitrogen? Here's less than 5. And you might be like, well, it's 6. But some of you might be like, the question asked before, well, it's still going to be 6 because you actually start with 0. So that's 1 day, 2 days, 3 days, 4 days, 5 days, and still 6 days. And this is a decreasing function. Now, example 2 is very similar to example 1. So I'm going to ask you to pause here and try example 2. This radioactive decay application question example that we went over, it's a simplified version. Real life is going to be a bit more complicated than that, but it's still going to be related to exponential. Now, example 2. Let's first talk about what each variable represents. X represent years, Y represent salaries, because the whole question is about salary. And 70, well, it's a little bit different, but you might be like, well, 70 is just the initial salary. Yes, it is. However, the initial salary in the question was 70,000. To indicate that, you actually need to be very clear. 70 represents initial salary in thousands. A lot of time when the numbers get bigger, it's harder for you to constantly write that many zeros all the time, which is why we'll simplify it. We'll actually say it in the label, if, for example, it's in thousands or in millions or in billions, so that you don't have to write that many zeros every single time you write down a number. 1.08. At least you should understand that 8% raise, that's where the 0.08 come from. But what about the 1? Some of you might be like, well, that 1 is just the original salary. But the original salary was 70,000. How come it's a 1 now? Well, to rewrite 1 is actually the same as 100%. So 1.08 is actually 100% plus 8% raise. And that is how we're getting close to rewriting a lot of situations using exponential, because this factor is something that's easier to represent. Next, better variable. Well, in the question they used x and y, that's clearly not very representable. The question is talking about salary, so we can use letter S for salary replacing y. We can also use letter T to replace x as time. So S of t equals 70 times 1.08 to the t power. Next, it's time to type in your calculator and get the table. And this time, well, something you need to understand is, even though the 70,000 says first year, well, typically you'll actually sign a contract before you start working. So before you even work for a single day, you already know by the end of the first year you're going to get $70,000. So that's why we will still count 70,000 as 0. But in the table, salary is going to be in thousands. So we're actually writing 70, and the next one is 75.6, etc. And now we can start graphing. Time is this time going to be in years. And a 0, 1, 2, 3, 4, 5, 6, 7. As for the numbers, we're starting with 70,000, and we need to go all the way up to almost 120. So let's go with 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and 130. We are starting with 70,000, and then 75.6, so it's kind of like in between. 81, slightly over, then it's 88. Next one is 95, and then is 102, 111, and 119. So it's going up very slowly, not much at all. Oh, I'm missing one. But one is at 2, it's 81. So there you go. And I can connect them. It's almost like straight line, but it's actually not. It's exponential, and it's going to grow faster and faster. There you go. Moving on. How many years will it take before your salary is more than 100,000? So there you go. 100,000 is right there. And it's 5 years. Also because you're beginning with the 0 again. 1, 2, 3, 4. Getting to that is already 5 years. How many years will it take for your salary to double, which is 140,000, more than that? You can do a few more calculations, and that's going to give you 10 years. Domain and range. Well, you're not earning salary by the day or in the middle of the year. You're signing the contract at the end of the year. That's why the domain is going to be 0 year, 1 year, 2 year, 3 years, 4 years, all the way up to 10 years. And for the salary, the range is also going to be these specific numbers because you don't have anything in between. And lastly, to set up, you got another job offer, 47,000 to start with 20% raise per year for 10 years. Which job would you take? Let's actually set up how to calculate the other one. Is y equals 47 times 20% raise means is 100% plus the 20% raise, which is 120%. In decimal, that is 1.2. As for which job would you take, you can plug in 10 for both of the functions. So you can actually calculate 47 times 1.2 to the 10th power, and then calculate 70 times 1.08 to the 10th power. See which one is going to give you more. And that is question F, which is the last of example 2. Thank you.